Another physics video presentation. So comments and then maybe some more Kip Thorne. You know, this guy deserves to be beat up on by somebody. It's just such bullshit. But anyway, it's all bullshit. So we'll wade through it, and I'll hold up pieces of the shit and show you. See, it's shit. Anyway, the Stack websites such as Stack Overflow and Stack Exchange are not there for the user so much as that you, the user, are there for the website. So what? I mean, I don't need to be told that it's a piece of shit or why it's a piece of shit. It's obviously these are Nazi-esque majoritarian dictatorships, and I don't even know if the majority reflects any real majority. It just reflects an internet majority of whatever nerdy kind of person you want to pick. And like Wikipedia, that's a huge flaw that they don't seem to have any mechanism to fix, in the sense that you have to put some kind of restraints on their fanaticism. Just like if the Catholic Church was in charge of anything, you have to put some sort of restraint on the fanatics. But yes, you just wouldn't let them teach biological science. And allowing this fanatic group of devotees to the standard model to control what is supposed to be some place that's going to get to some sort of truth is just bullshit. Now, if all you're talking about is programming languages and programming code, there's not much controversy. I mean, either a hunk of code works or it doesn't work. I don't think Stack Exchange sits there and says you can't post any code that violates Microsoft policy or something. They don't bother doing that because they're not fanatics about programming. In the sense they don't all work for Microsoft. But clearly, if they all did, or they all worked for Google, you'd say, well, this is a bullshit website. And frankly, if you're going to allow a physics website to be just run by the devotees of the standard model, then you're just going to get bullshit, propaganda. You are supposed to be helping build a database of, Catholic reputations, crap that defends the religion and don't allow any dissenting voices to ever be heard. Of unique questions and answers. Well, the questions are not unique, which is the joke here. You can't ask a question off the standard. You have to say, please, smart person, tell me the truth about. I'm really dumb. Give me an answer. How come water's wet or something? I mean, they're not complex questions in the first place because they won't allow you to get to something complex. Because if you get to something complex, that's going to get to something that might involve something where you're going to have a discussion about Copenhagen versus many worlds or some other more complex subject that they just will not touch. It is not a friendly, chill place to hang out and talk about problems. Well, who was arguing about a friendly, chill place? That's not my expectation, clearly. I'm not looking for a friendly, chill place to have some trivial conversation about physics. So, why are you giving me this sermon, fuckhead? My expectation is that this place has some boundaries where they're trying to consolidate all the noise and turn it into a place where you can find evidence of a truth, a good argument defending the truth, that's what it would be doing, okay? And instead, any argument is thrown in the garbage. Now, they could clearly put what they think is the right answer on top, and they can put wrong answers in a category called, we think this is a wrong answer. And if they had any respect for freedom of thought, if they weren't fascist, that's what they would do. They would allow people to choose to read discussions they thought were interesting instead of telling them what are interesting discussions. And clearly that's what they're doing. They're telling you clearly, these are the only interesting discussions. There is no other interesting discussion. If I don't like it, if I'm not interested, you're not interested. They're clearly doing that. And ask questions and learn. Well, again, learn what? Learn propaganda. Learn how you can distort the evidence. Learn how you can lie about what the evidence is and get away with it, because any dissenter who points out you never did that experiment Eddington admitted he wouldn't stake his life on the results of the experiment. Why are you saying it's proof of something when the guy who did it actually said, I wouldn't risk anything important on the credibility of this as evidence? He says it. The guy who did the experiment says it, and you still think it's unimpeachable. I personally do not like these websites, so then why are you're essentially defending them in a way, so why are you doing that? Why don't you just say, yes, they're just fascist bastions of groupthink, and that sucks. And they ought to have some mechanism to prevent groupthink from controlling what is supposed to be some sort of resource that should be valuable to any human being. I use them more for programming than anything else. Well, again, those are two different subjects, aren't they? I mean, politics and, I don't know, bird diseases or something. I mean, some things are controversial. Some things really aren't. It is the same issue regardless. It's really not the same issue. They're not the same subjects. So, and, you know, fuck you for presuming that I had some expectation of having a friendly, chill place to hang out. I wasn't looking to hang out. I was looking to make a on-subject, thoughtful conversation about the facts, and about the fact that if you look at the facts, you can't prove jamming isn't the reason. There's wave interference in the radar experiment intended to duplicate the two-slit experiment. I mean, it's not really a two-slit experiment. But anyway, so whatever. Can I say it? I think I will. Fuck you. Yeah. Just for what you're implying, as if I had the wrong expectations. I didn't have any wrong expectations. I expect them not to be disgraceful cowards. Now, that's not a wrong expectation, shithead. Remove that nonsense. Alright. Perv Action. Great screen name. Well, why not just pedophile do all the time? I mean, what is that? Perv Action. So I'm supposed to take you seriously? Oh, yeah, I don't think so. The vulnerable part about this to me is the consistency with which gravity appears to act. So how does that make anything vulnerable? Consistency is a kind of an invulnerable thing. But anyway, considering all of space at once, we can see fluctuations in literally all kinds of radiation. How so? So this is just the statements people make. Considering all of space at once, we can't even do that technically because frankly, the universe is too big, and we're going to get messed up just because we can't see all of space now. We can only see far away then. See, this is all this time crap. It's really not all that complicated, but as stated, you know, there's little nuances here, and you got to keep aware of the nuances. We don't see things instantaneously. We can only see things far away, with the implication of it's going to take time, yeah, to see it. And so we can't even consider the whole universe at once because big parts of it we can't see for another billion years from this location. We just can't see it. It's completely different than it was. It's something new now, and we can't see it. So how do you consider it? And then how do you see fluctuations in what you can't see? Oh. I mean, shit. So this is, I totally disagree that you have any evidence of this statement that you see fluctuations in literally all kinds of radiation. I would argue you don't see fluctuations. That's exactly why you can actually see galaxies that are billions of light years away. You see the stars in all the right location, and they're not all distorted and perverted and pulled all over the place. So where are these fucking fluctuations? You're viewing things at preposterous distances, completely consistent with what your expectations would be that they would look like. Where did the fluctuation happen? Oh, Christ. Why is the force of gravity always the same over all of space? Does sound kind of convenient. Why would it be different? Could be just as easy for me to ask the question. Why would it be different? Why is it different? Let's say if it was different all over space, then I'd have to ask, why is it different? Must be God, right? Because there's no reason it should be different. Something has to make it different. I mean, so that doesn't make any sense. Of course it should be the same, because it's all generated by the same thing, which is nothing, essentially, next to nothing. Whatever next to nothing is, that's what's generated by. So why should it be a fancy painting? The universe painted it when the universe was in its most simplest form. So it should look pretty much like, hey, it's all blue. yeah. That's all he knows how to finger paint. It's blue. Idiot. All right, which brings me to another question. Well, yeah, probably another stupid question premised on bullshit with a little capital crap. Is it always the same? So you're questioning your own question. Brilliant. I just love that kind of rhetorical kind of horseshit where somebody pretends to ask a question seriously and then basically just says, oh, fuck what I just said. Oh, this is damn annoying speaker noise. I have to get a new speaker wire. Well, I have to wire it into the damn speaker, which I really don't want to do. Alright, brings me to another question. Is it always the same? Well, that is an important question, because you could argue that the whole reason why galaxies are much smaller in the past is because in the past there was in fact less or more gravity. I would argue obviously more. And it is the fact that when you store matter in clumps, you have to take it out of the field, the energy, and the energy in the field does change. It does fluctuate over time. So we're in this stage where basically the game is that the matter has been storing, okay, and it's reducing the amount of gravity existing, and now the matter that was stored is expanding, and it will eventually collapse and go back into the field, and then the field will have strong gravity again and collapse everything again. It's the same. It's a shame you don't have access to spacecraft to experiment with. I mean, it's a shame I don't have all the answers instantly placed in my head, and therefore I wouldn't have to have any conversation at all. It should be possible to weaken the effects of gravity for an object, let's say a cue ball, that floats in space by having it float in a sort of maze made of empty space and a couple of objects massive enough to influence its trajectory. Well, again, it's not influencing its trajectory overtly. I mean, that's the emergent property. The fundamental property is those objects are interfering with the field that you're talking about always being the same. But anyway, the field of energy, and that they're doing this shadowing thing. They're absorbing energy that would have got to me, but it doesn't get to me. So I'm the cue ball. I'm floating around in space. There's other objects. They will influence and they will change my trajectory. So now what are you saying here? Why is this at all interesting? Wouldn't it be possible to create purposefully overlapping gravity shadows? So again, the whole point of gravity is to point out that it always adds up. So if I have one thing in the field and I add another thing, this thing doesn't block something and no, these are two independent objects and they both create the same effect. So it's just like magnets being stacked on top of each other, they just add up. So now I have this much total mass in this area. So you could just draw a circle around both of these things, create a center of gravity and say that's essentially the gravity of this thing from a distance. It'll be exactly like these two things were smashed together, but they were this big instead of this big. So it always, there's no, gravity always adds. You can't block a shadow from something that makes shadows. Its capacity to shadow is their net capacity, always. Alright, overlapping gravity shadows filter the effect of watching the behavior of the cue ball. Let's see, overlapping gravity shadows and filter for those effects by watching the behavior of the cue ball. Right. Well, the only you'll not filter anything. Again, as I pointed out, there's only a tiny difference between the gravitational profile of this and this. Okay, and it just has to do with how much you're spreading. This spreads the radiation into a wider field, where this is a narrower field of influence, and that's the only difference, theoretically. So it's a tiny amount of difference you can make in the field by manipulating masses that already exist. You have to be, the only way you manipulate it is by moving far enough away from it that you can't tell. It's like having two light sources. You move far enough away, you can't tell there's two anymore, because the distinctions become irrelevant over distance. All right. So I would argue that this is a not very useful minutia. That's what I'll say. I don't see any. I didn't see you getting to anything. Not hitting anything fundamental here. Your argument is there's something strange about the idea of consistent gravity. Well, I would argue there's something strange about inconsistent gravity. So, you want to talk about origins of the universe again or something? I don't know. We already know it's pretty consistent anyway. From any range we're going to move into, gravity's pretty consistent in terms of the density of the pressure is even, and the pressure always affects things based on their mass. So the more mass I have, the more pressure I'll interact with. That my little atomic bits are the ones collecting the momentum. And that's what you're doing. You're collecting momentum from the field. Sheesh. Okay. And I think that's it. Yeah, thank you. Okay, well, okey doke, we'll go with that. Alright, so I found some other Kip Thorne. Oh, sorry. It really does annoy me. I just unplug it. Fuck it. Then I'll forget where to plug it in. Anyway, it's too bad, huh? Oh, what a shame. Just take a quick look. It looks like it just goes in that green goes in green kind of thing, maybe. Maybe. Can't always trust that. So this is a 2013 interview. So before they did the big "we've done it," before he got his Nobel Prize. So these are pieces of an interview, and so it's good enough. And you can just, this is 100 years after Einstein, and you're just, you can just sit here and say, oh, so in 100 years they haven't figured out a way how to describe this thing that makes any sense at all still. They're still not making any sense. I mean, they still haven't found clear, articulate language to describe the nonsense they're promoting. Which is surprising. Oh, I have to plug in the speaker. Yeah. I wonder how I'm hearing that. It's coming out as something. That's funny. That's weird. Sorry. I find it curious. I don't know. I find it curious that I can still hear it even though I had the speakers unplugged.
Most people is to talk about something that's so absolute, so given that it just seems like part of our world, and yet
right. So to you, the people, it all seems like, I guess that's the way it works, right? You've all, oh yeah, I totally get this bent space crap. It totally makes sense. Like I said, I think obviously having an easy analogy, doing the bent curved space thing, the bowl thing. I mean, Newton could have done that. He could have said, this is a rough approximation of gravity, and then everybody be hailing Newton because yes, that's the way to, we have an illustration. And it makes no sense because again, it's a two-dimensional thing and it's using gravity to give you the understanding of gravity. You can't use the very force you're supposed to be explaining to explain your force. I mean, it's just, that's cheating.
Space and time have a very integral relationship.
So again, this is supposed to be in some way everybody gets that. And well, I never got any idea of how at all they would be related. I mean, I never was able to imagine this idea that somehow time is some dimension. No, it always seemed like it's just a function, and especially because of Einstein. Especially because, well, look, I can't say that I can't say I needed Einstein to say it to understand that, in my opinion, once you know light moves at a certain speed and that you can under no circumstance change its speed, that now the game is over. Time is a function because everything's going to be dictated by how fast that thing moves. You can always use it as a ruler. It's the universal ruler. It always works. It always tells you the right answer, kind of thing. So there's just no way to manipulate time. You're stuck. It is progressing from the past to the future. It ticks off, and it has everything to do with being able to move something in the universe. You can't move anything except at the speed of light. That's the fastest you can go. So that's time. You don't need any more. Problem solved. Time is not a conundrum of any kind whatsoever, unless you need to believe there's a way to get to the past. Because that's it. Getting to the future is easy. We already did that with Rumpelstiltskin, or whatever the hell his name was. You just go to sleep for 20 years, under a tree, and you can get to the future. You can time travel.
Indeed, Galileo, Newton, and all of the great scientists before the 20th century thought of space and time as absolute and having no real intimate connection.
Well, we'll see, what does that even mean? No real intimate connection. What does that even mean? I mean, it's all these little words where you say that these aren't even words you should be using. Is there an integral connection between time and motion and distance and space? And there really isn't, beyond the fact that there's one thing, the speed of light, that's always consistent in terms of migrating through distance. A certain amount of distance will take a certain amount of time, period. End of that. We have a constant. And that's still under no rational debate. There's no evidence that was acquired between Newton and Einstein to demonstrate something else was true. So Einstein is just telling a story.
But Einstein taught us otherwise.
He didn't teach it, actually. So that's another, these are words they use. He proposed a simple model, okay? Unlike Maxwell, he didn't write 677-page papers or anything like that. And the proposal, if you think about it, creates paradoxes, clear paradoxes, the twin paradox, different paradoxes that arise out of this theory. And so, in my opinion, it demonstrates it's an incomplete model. It hasn't been hammered enough to be called finished.
Einstein's great insight in 1905 was to recognize that space and time are personal.
So more bullshit. So he doesn't want to say relativity. He wants to say personality. Why would you make this? Why would a physics person who likes physics sit there and start putting human, doing this anthropomorphizing bullshit of trying to make physics into some sort of human adventure story?
Your time flows at one rate, my time flows at a different rate.
Right. There's no time thing. Like, okay, I'm in a time bubble, and everything in my little time bubble is moving or flowing at some sort of rate. No, the whole point of Einstein saying the speed of light is always the speed of light. You can't make light go faster. You can't make it go slower. He should have said you can't bend it, but he wasn't smart enough to figure out ahead of time that that's the right way to go. Well, he wanted to prove his stupid, idiotic premise that somehow all acceleration is the same when all acceleration isn't different. You get accelerated by rocket engines, it's different than getting accelerated by gravity. Not in some huge, substantial way different, but it's different in sort of the force takes time to get through you in one case, and it takes no time to get through you in another. Gravity's really efficient at moving your little bits. When you take a solid object and you take another object and you smash those into each other, transfer the force, that's a lot less efficient, especially in things called atmospheres and all of that kind of crap, especially in mediums that have more force opposing your motion.
Right? What you see as space, I may see as a mixture of space and time in a very precise sense. It's a little hard to...
What you see as space, I might see as a mixture of space and time. So this is how they're explaining something. No, we'd all, if we're in the same frame, we're going to have to see the same thing. So that doesn't make any sense. So if you said, well, if I'm all the way on Pluto and the moon blows up, you're going to see the moon blow up before I see it blow up. Well, yeah, that's going to be true. No problem there. We're going to see the world different then, because yeah, it's going to take time, okay, for the light to travel. I don't get to know what's really happening. I only get to know what's happening based on a lag, okay, a vision lag. So there's vision lag in the universe. There's no time dimension. There's just a vision lag.
grasp. Let's begin, say, with time. Einstein's special relativity and general relativity tell us that if you move...
This isn't really true. They both don't tell you the same thing. So, one of them tells you about acceleration and makes an argument that the special case of acceleration. And the other one talks, about other kinds of motion, velocities. And the two things are, in a sense, I would argue, acceleration is a form of velocity. It has the same effects, even when your acceleration isn't apparent. So this is another argument where physics doesn't really understand that physics always has to be sort of understood that there's only one universe, and it's the tiny one. The tiny one comes first. That's where all the action is. That's where all the real laws are. So when you want to talk about something happening, you have to be aware of the fact that you're a collection of stuff, and that while some of your stuff might be moving this way, some of your stuff's moving this way, that it all has different momentums. And that the truth of the fact of the matter is that even though my whole collective is not moving down, okay, I don't appear to be moving, I am applying pressure through the earth, into the earth. I'm denting the fucking chair. There's just no doubt about it. And the earth is pushing back, okay? I'm creating heat and energy. It's reflecting that back and pushing me back. And those accelerations are real. They're real movements of physical bits of electrons inside of me, and that's happening. And so if you're going to talk about what the effect is, although I don't look like I'm accelerating, I am in fact accelerating. I'm moving. You don't see me doing it, but I'm doing it nonetheless. And so I have a velocity, even though I don't have a velocity in collective space. I have a velocity in internal space. The little universe inside of me is doing a lot of moving. There's a high velocity inside of me. And so that's sort of what Einstein, he didn't make the clear connection, but the point is that acceleration, like velocity, will cause time dilation. And so the connection is just an understanding that even when you're not moving, you could be moving. Well, that's not the right way to say it, but because I wish Einstein was that clear. He should have just said, look, when you're being accelerated, you're doing a lot more moving than you actually see. Okay, so your velocity is higher than you think. Your apparent velocity isn't your real velocity.
with a high speed past me, and I watch clocks that you carry tick. Those clocks.
So again, this any intelligent person, in my opinion, knowledgeable, thoughtful, ought to recognize that clocks are made of different mechanical systems. They're going to be affected by different changes to the environment. I can't put a regular watch underwater. Breaks. Doesn't work anymore. Doesn't count time correctly. Can't get a digital watch too hot. Doesn't count time correctly. Can't do a lot of things break clocks. So let's not talk about clocks. Let's just talk about the function of photons. And the migration of photons across distance never changes. It never moves faster. It never moves slower. It never covers distance any other speed than the speed of light, the speed of force. And that's it. That's the only clock we should care about. The only clock that matters, and this is what Einstein was saying, the only clock that works all the time is the photon. You can't put it under, you can't dip it in water, you can't break it. It doesn't break.
Will appear to me to tick more slowly than my clocks. But at the same time...
So again, it's just based on the premise that somehow your clock is consistently, whatever your clock is consistently measuring your velocity. So the point being made is velocity, all right, causes changes to mechanical systems. And so then they're going to start, they always, instead of staying on the subject of photons, they start talking about radioactive decay. And that just confuses people too, because they think of the radioactive decay as the radiation, the speed of the radiation. But no, it's not about the speed of the radiation. It's about how often the atom spews the effect of decay. And so radioactive decay isn't, Einstein didn't say radioactive decay, you can put that underwater and it acts the same. We already know that the decay rate is, you can change the decay rate of any substance by just putting more of it together. If you put more uranium closer to other pieces of uranium, instead of being a decay rate of 10,000 years, it has a decay rate of 5,000. So, I mean,
You're going past me. Of course, you see me moving relative to you. You look at my clocks. You see my clocks tick slower than yours.
So again, what you see is just another canard of this whole conversation. Now, the easy way to understand, okay, that time can fool you is just by saying, okay, there's two things happening in two places. And if I change where you're located, well, then you know that, yes, it's going to take time for the light to get to me. So one guy's going to see it sooner than the other guy, right? So I put the event in the middle and I put two people here. Well, when it's in the middle, they both see it at the same time. If I move the event closer to this guy, then obviously he sees it first, this guy sees it second. That's not dramatic. Now, the second component to this function is the fact that mechanical functions are being degraded by velocity. So the faster you're going, it's kind of like you're getting cold. You're getting slower. So everything you perceive is slower. So if you had a computer and you gave it a lot of velocity, its clock rate would slow down, which means it could process less and less and less information. It would basically make it a dumber and dumber computer the faster it went. It would be less able to process the information. So everything would appear like it's moving way faster than you are. And nothing changed in the universe. Nothing's moving faster than it was before. It's just that you're being required to process a lot more, and you don't have the faculties for it because you are processing things slower. So the two effects are multiplying. You're going really fast, which means things are happening really fast, because you're moving into them. You're causing events to happen sooner than they would have happened to you. You're seeing them sooner. You're moving towards the thing. And so obviously the thing, as you're moving towards it, okay, you're absorbing the time. This was, time 1, time 2, time 3. You're absorbing the history quicker. You're not making it instantaneous, but you're making it happen in a smaller amount of time than it would have if you stayed stationary. So by moving, you increase the time you'll get the recording. You're speeding up the tape. Okay, there's a tape recording of the event, and you're speeding the tape up. That's another analogy. But like I said, he's had 100 years to figure out how to articulate this mush, and they still can't do it reasonably.
So I see your clocks tick slow. You see my clocks tick slow.
Okay, well, you see. So this whole argument about what you see. So there's two effects, right? There's this real effect of being in a different place, which is going to cause, you're going to have to wait for it because you're further away. the Pluto moon example, right? I mean, okay, the moon blows up, the Earthlings are going to see it long before the Planosians see it. That's just obvious. And then you have this second effect. So it's like gravity. You cause gravity and you're affected by gravity. So there's two effects here. You're stuck in a world where you can only get information at the speed of light. And then on top of that, if you have a velocity yourself, your capacity to process light changes because you're getting hit with too much. You're changing how fast the events are happening. So if you're moving away from something or moving towards something, that's when it gets, there's two different effects. Okay, the fact that your perception is slowing down, you're becoming less capable of, as your frame rate is retarded, so you can't see the stuff, the detail. It's flying by you too fast. Let's see, because you're slowing down. I don't know how to say that exactly the perfect way. But they're two different effects, okay? Just like the difference between the gravity you create and the gravity you fall into are two different things. They're two different things. What happens to your perception, what you're seeing, and the physical effect of distance is one effect. The physical effect of retarded perception is another one. That's all. And so obviously the two of those combined can create paradoxes, but they're not really paradoxes if you understand that you can't say something like, well, what do you see if you're going at the speed of light this way? Well, you won't be seeing anymore. You're physically not functioning as a seer because now you're traveling huge distances essentially with your eyes closed. I mean, there's no perception. A billion years go by and you didn't notice it. You're moving you're so cold. I mean, just think of speed as cold. And so you're getting cryogenically slowed down. Everything mechanically, you're just mechanically slowing down. And your capacity to perceive events is slowing down. And so it's like there's the frame rate thing. It just clicks off. Half the universe you don't get to see. And all of a sudden things change and you're like surprised. Hey, how did all that stuff change? Well, it changed because your perception is moving slower and slower.
Crazy. That's crazy. That's crazy. It isn't possible. But it is possible.
It's not possible.
It is one of the peculiarities. It's possible because what you regard as two simultaneous events occurring at the same time, but at different.
Right. So this is where it gets just silly, right? Now we know there's simultaneous events, and we know that in no universe are they non-simultaneous. So if I make two things happen at once, they happened at the same time. And perception can't change when they happened. And all you can do is explain why somebody saw it different. And obviously, people are going to see it different, as I just explained, because if the two simultaneous events are happening out here, and evenly spaced, and you're in the middle, then fine, they're simultaneous. But obviously, if I'm over here, they're not simultaneous, because I'll know about this one before I'll know about that one. But there will be no doubt that the two events were simultaneous, and you'll never change that fact. All you're going to change is how you're going to perceive the information that has to go at the speed of light away from them. That's it. And if you have a personal velocity, you're going to change how well you can see, period. It's not going to change the fact that you're closer to one event than you are to the other event. You can't change that fact. So they're mixing these two subjects, and there's just no need, because in most cases, the effect of one thing has nothing to do with the effect of the other. The fact that your perception is slowing down isn't going to have anything to do with the effects of you having a biased perspective, that is, being closer to the one object than you are to the other object, and therefore you know about one object sooner than you know about the other object. I mean, that's just as simple as understanding that what's a good example? Thunder and lightning, having different speeds. I mean, you understand that, oh, the two events actually, the one event happened at the same time. Obviously, the thunder is taking longer to get to me than the light took to get to me.
Different locations in space, I don't see them as simultaneous. If you have two firecrackers and you carry them with you and you move at high speed, and you set them off simultaneously, measurements that I make will show the firecracker at the back go off first, the firecracker at the front go off afterwards. So there are weird things in how time seems to behave in simultaneous.
So again, it's not really weird, and it's all mechanical. You can understand exactly mechanically why you are misseeing it. But that's all you can do is missee it. There is no change in the actual physical universe. The universe says, yes, there was one event, they were simultaneous, that's it. It's not non-simultaneous in any way, anywhere. The true history, the true action, the true cause and effect event doesn't change.
And that goes also into weirdness about space. You would have said, as you go, from your point of view, what is space? Well, it's all those events like firecrackers going off that are simultaneous. And so if you have firecrackers all over the room and you set them all off simultaneously, you say, well, I had the space at that moment of time. There was a space, and it was the space in which the firecrackers went off.
So did that make any sense at all? I mean, it doesn't even pose something that is at all mentally challenging. They all went off at once in space, yeah, so no problem. And yet he's talking as if there's a problem there.
But if I see all the firecrackers going off at different times, I'd say, no, that's not space. That's a mixture of space and time.
Okay, so and obviously I'd be an idiot to do that, right? To not understand that because I'm far away from something, it takes time for the light to get to me, that I'm not going to be smart enough to figure that out? Well, of course I am. So why would I think that there's any problem? I wouldn't think there's any problem. I wouldn't have any expectation that I'm going to see something happening a billion light years away that really is yesterday or something. I'm going to know that, no, that's a lot longer than yesterday.
Yes, there was a space, but you had time in there because some of the firecrackers went off first. So in that sense, space and time are personal.
So in no sense are they personal. It's obviously we're personally interacting with the universe, but there's no. The truth is that you can dissect your personal position. You can understand your personal position in the universe, and they're basically saying, don't try to understand it. In a way, just be fooled by it. You're seeing an illusion, something that's not true, in the sense that the light is, because of distance, the information takes longer to get to you. That's the truth. So why make it any more complicated than that?
What you see as space, I see as a mixture of space and time.
Now the critical...
Right, and mixing how? There are two completely different things, and the only thing they have in relation to each other is distance. And distance, because of photons, takes time to see distance. Yeah, that's all. I mean, what can you say? It takes time to interact with things that are far away. There, is that complicated? It takes time to interact with things that are far away.
factor in making this happen is the standardization of the speed of light from Einstein's special theory of relativity.
So you don't need any special theory of relativity to understand that, yes, light has a speed and it's a constant speed. So Einstein didn't invent that notion, and so this is all kind of bullshit. People had already established that before Einstein.
How does that work?
Einstein postulated, but it's maybe better to say that he intuited that the speed of light.
So just more crap. If you want to, you want to diminish somebody else's thought or proposal. You just say it was, oh, he intuited it. Fuck you. I would blame your whole nonsense on intuition, but I can't even say it's intuition. I think it's childish delusions, immature thinking.
Light will be the same as measured by everyone, no matter how they move through the universe.
So this is just more nonsense. I don't think Einstein said that. What he's saying is that light is impervious to change. It always functions the same way. There's no frame that light can't travel exactly as light through. So light's the only thing consistent in the universe. The speed of light is the constant. And as long as you pay attention to that, as long as you keep your eyes on that ball, everything else will be understandable.
Now, in reality, if you go deep into the philosophy of science,
Yeah, the philosophy of science, more just rubbish talk. There's such a fucking such thing as the philosophy of science. There's either statements made asserting a truth. I'm asserting this is the truth. Now I can defend it with evidence, or I can defend it with nonsense. If you're defending it with nonsense, you're doing philosophy. Okay, if you defend it with nonsense, then you're just doing logic. Evidence. You're defending it with evidence.
Really going on here is Einstein says if you define your ways of measuring space and time, define the rate of flow of time in a manner that makes the laws of physics look simple. So that, for example, time is ticked at a regular way by atomic clocks.
Right. So again, he's going to atomic clocks and saying that's the standard. When Einstein was saying, no, atomic clocks aren't the standard. Photons are the standard. The speed at which photons move from point A to point B, that's the constant. How fast something radioactively decays is, again, one of these things that can be affected by velocity. You can't change the velocity of a photon, so therefore it's impervious to change. But you can't change its velocity. Material objects, you can change their velocity. And by changing their velocity, that means you're changing the speed of the internal bits, and therefore breaking, okay, in the sense that you're taking circles, and you're forcing those circles to essentially process, to have velocity. That means it takes longer for the circle. If I warp a clock, okay, into some other shape, if it's no longer on a center of gravity that spins, and I force it to spin on a line, it's going to take it longer to go around the line. So as you process the circle to move it in a direction, you're traveling a much longer circumference. So you can't go as fast. You can't do as many circles in the same amount of time because you're traveling more distance around the bigger circumference. That kind of thing. Now, I don't think Einstein's ever stated it that way, but that's how simple it is. Velocity breaks the fact of motion because you always have to account for the new motion. You had the old motion, and now you're adding a motion, and the added emotion takes time. You have to take time out of the system to account for it.
As atoms vibrate in a molecule, it's ticked at a regular way by atomic clock. And if you define space in such a way that the laws of physics look simple, so that if you then measure the distances between atoms in a lattice, those distances are always the same. If you define things so that length and time so that laws of physics look simple, then the speed of light will always be the same for everybody.
And Einstein said that regardless of what you're saying. So again, the argument is that Einstein clearly pointed out that light is the go-to for consistency. And so it's the reference. It can't be, you can't make the light go faster by shooting it off something moving. So I can't make the speed of light faster by having a photon fly off of something moving forward. And I can't make it slower by having it fly off of something moving backward. It's that simple. You can't break light.
And he recognized that. he said, this is the way we should define lengths and time, and so that the laws of physics look simple. Having chosen that, made that choice.
So he used as the example radioactive decay. You see that the dodge here. He used this as the example, the radioactive decay of clocks, which we know breaks. Okay, the clocks break. We know decay isn't the constant. That you can change the decay rate by heating uranium up. You can change its decay rate. So, I mean, it is not a constant clock. You can't heat photons, and you can't freeze photons, and you can't in any way change their consistent reliability in their motion. So this is just horseshit.
Then the speed of light is the same as seen by everybody, and then time is personal. Space is personal.
So this is, how does this language do anything? How is this in any way rational physics? Just talk about personal crap. Of course, everything's personal. Bullets are personal. Everything that we interact with is personal. So everything's personal. What does that even mean? I have a personal. The atmosphere is personal. Oxygen is personal. The moon is personal. It's all personal. No, it's not personal. These are real objects in real space, and you're just one stupid thing interacting with them. And we're trying to model the universe. You don't model it from your personal perspective. Oh, it's just such bad language to throw into scientific conversations. To throw the word personal in, it's just such a pile of crap.
But very deep inside.
No, personal is not a deep insight. Yes, and there's nothing deep or difficult about the concept that establishing that light has a constant speed. Again, that was always something that seemed perfectly acceptable as a statement. Once you hear it and you know it and you think about it, yeah, that works. It works for me. So I mean, I don't need relativity. I don't need all this crap once I understand that. Yeah, photons move distance at a constant speed. I can't make a photon get from point A to point B any faster or any slower. I mean, yes, I can put a medium in the way like a piece of glass, and I can make the photon move a lot more distance, but I can't change how fast the photon is actually moving.
Means that if you're traveling very rapidly towards a light beam or traveling away from the light beam, which in normal sense, if we deal with sound, would have different characteristics, with light it would be the same.
Well, you see a Doppler shift, so you see if the light has modulations on it, waves. If you move toward the source, you see the wavelength shortened, but you don't see the.
Yes, that's right. So if it was cannonballs and they were 3 inches apart or whatever the thing would be, and you were moving into the cannonballs, okay, then you're going to change that 3 inches. It's going to be perceived the same when you're moving into it, and then when you're not moving into it, the two will seem different. They'll be shifted. So the frequency of the cannonballs will appear to be different than it actually is because you're moving into them. So that's kind of obvious. You're shortening the distance between you and them. But this next statement.
The speed changed. So the wavelength is shortened, the frequency goes up, but the speed is totally unchanged. That's the one constant.
All right, so this idea that you can move into something and you're not changing the practical fact that it's going to arrive sooner is idiotic. So, I mean, obviously if there's two things coming towards each other, they're going to arrive, okay, faster than if one thing stays here and the other thing has to move this distance. They're going to arrive slower. And if neither one's moving, then the arrival date will be really, really, really long. So of course you can change the arrival date, which is that's what perception is made out of. When do I expect it to get here? Well, how fast does it look like it's moving? So obviously if I'm moving towards something that's emitting light, it's going to be looking like it's heading right for me. It's moving faster. So if there's a stationary object and I'm running towards it, it's going to look like the stationary object's moving towards me. If I don't know I'm moving, of course it's going to look that way. So, So, if Einstein was saying that somehow it won't look that way, that would be stupid. So, I mean, but obviously I'm not changing the speed of light. I'm changing at what distance the speed of light has to travel. Obviously, I'm moving towards something. The distance the light has to travel is shorter. I mean, it's impossible not to perceive it as moving faster. Now, the photons themselves aren't moving faster, but the object is what I'm seeing the photons leaving. And if I'm changing the distance between how far I'm away from where the photon left from, if I change the position of point B, I mean, obviously, the time it's going to take for the light to get to point B is going to change. So again, this can be mechanically understood.
That results from asking that the space and time be defined so that laws look simple.
What are the implications of having space and time so integrated and so personal?
Well, when Einstein recognized this weird behavior of space.
All right, so there's no weird behavior, number one. Number two, I mean, it's perfectly understandable. And there's nothing personal in the sense that this is something that happens to all objects that move in a particular way. So, I mean, whether it's batteries or people or whatever, you don't sit there and say it's personal to the battery. I mean, this is just baby talk. Injected for what purpose? Why would they do this to physics? Why would they do this to a discussion of a cause and effect universe, except to make it religious-y?
Time. The word he uses there, relative. I prefer personal.
Yeah, it's relative. I prefer personal. So, and again, relative is a simple concept, right? We can tell you're standing behind me and there's another guy in front of me. Obviously, relative position matters, depending on what you're going to see. One person will see my face, the other person won't. I mean, duh.
They are relative to you or relative to me. And that's where the name relativity comes from. When he figured that out, 2 years later, I think it was, maybe 4 years later, one of his teachers from school, named Hermann Minkowski, looked at Einstein's laws and said, hey, I can write these laws in a much more beautiful mathematical form if I regard space.
And this is all just more personal, subjective crap. A beautiful form, says who? Beautiful how?
Space and time is unified into a single thing called space-time. And this space-time has then 4 dimensions, 1 dimension of time and 3 dimensions of space.
It means absolutely makes no sense. The 3 physical dimensions, there's no way to make a 4th one and keep rational geometry. So what's the point of it? It doesn't exist as anything connected. There's no connection between the 3 physical dimensions and this 4th dimension of time. The function of time affects everything, but the whole point of the root of what Einstein's saying is the effects are dictated by this law that photons will not be fucked with. You can't change them through giving them velocity, where you'll change material objects by giving them velocity. You'll make them colder, in a sense. You'll cryogenically dull their interaction with the universe.
And I can formulate this unification in such a way that I can understand the personal nature of space, the personal nature of time.
This is just more baby talk. It's baby talk. I mean, the physical bits in the universe have physical locations, and they're not locations in anything called time. There's no dimensions where you can go through. Well, anyway, there's no point in me saying it. There's just absolutely no evidence for any time portals.
That if you move at high speed relative to me, you are in some sense slicing through space-time, taking a 3-dimensional surface in space-time that is different from what I take.
No, and the only evidence we have for this is the effect on material clocks of sorts. So they don't do these experiments with regular mechanical clocks because they break in all kinds of funky ways too. A pendulum clock isn't going to like 1g of acceleration. It's not going to work. Lots of things are going to break when you accelerate them or give them velocity. Acceleration having more of an effect probably than velocity. So once you have velocity, your pendulum will work fine, but while you're accelerating, your pendulum clock is broken. And as pointed out, the only clock you could really depend on to survive both events is the light clock.
But there is a unified space and time, all unified together. Einstein, when he saw this reformulation of his laws, he didn't think much of it. He wrote that Minkowski is taking basic physics and making it look complicated. He's building this fancy mathematics that...
Yeah, well, again, he was right in that initial description in the sense that this isn't that complicated. And it only becomes complicated when you force it to do things that aren't necessary. So Einstein broke his own theory by speculating about this idea that all velocity is indistinguishable. And I don't know how he broke his understanding, because it seems that he did understand the thought experiment of a light clock, and then you move the clock and the light will look like it went down when obviously it didn't. The surface moved up. The photons did their straight line thing, and for some reason he thought there was some reason he needed to make acceleration and gravity do the same thing and started bending photons, and that's where he broke his own insight.
And it just isn't needed, it isn't appropriate, until several years later he discovered he had to have that unification of space and time in order to formulate his laws of general relativity. And
there's no laws of general relativity, so more horse shit.
So it's built deep into the laws of warping of space and time.
Again, there's no laws of the warping of space and time. All there is laws regarding the breaking of all the clocks. And they believe that all the clocks break the same way, and that's obviously nonsense. I can catastrophically break a clock, or I can just make the clock work badly or tell a bad time. There's lots of variants to this breaking, and I can give you just this simple argument. You know that if I move you at 2 or 3 G's, your face starts to deform, everything starts to get crushed. If I moved you at 50 G's or 150 G's, you can get the idea that you're going to get squished like liquid into your seat. You're going to be physically destroyed. You're not going to survive that kind of acceleration. You physically won't survive it. Okay, you won't slowly time dilate. You'll be physically turned into soup. And that's the physical fact. So why are you pretending the facts are some other thing? If I put you in one of those little cyclotron things, one of those little spinning things, and that they use to separate liquids, that's exactly what will happen to you under those same circumstances, is you'll be spun into goo. And that's what you'll turn into, goo. And you won't do it by some perfect scale of time dilation or something. No, you'll just break catastrophically. So there's no rules about any of this, except for maybe on the atomic scale. There's a rule about the net velocity and what you can accomplish. What you can figure out, what the overall motion of a system is, what the overall heat of a system is. And argue that there's a certain velocity built into that system. There's a certain velocity inside the sun. Bits of it are moving like the Earth. It's spinning in there. They speculate that it might take 1 million years for a photon to get out of the sun. Okay, it's moving around inside all of that motion. It's reflecting, bouncing off of electrons all over the place. And it takes 1 million years for it to get to the surface.
This is Einstein's laws of general relativity, this unification. You can't formulate laws of warped space-time. You can't get predictions of black holes. You can't get predictions...
Right. The predictions of black holes is, again, completely speculative, so this is more stuff where they don't have any hard evidence that you can smash electrons and protons into positions that essentially violate the repulsive facts. Like you can take your magnets and smash them all at the wrong poles against each other, and that somehow you won't create enough outward pressure to just say blow the whole thing up.
Of a warped side of the universe, objects in the universe made from warped space and time, such as the Big Bang singularity where the universe was born. You can't get that out without unifying space and time together in the way that Minkowski taught us how to do.
Does that mean that...
So again, there's no evidence verifying any of these mathematically precise effects of velocity on physical substances. There should be a consistency, you would argue, about, say, a radioactive isotope, and so its decay rate, and I move the isotope at different speeds, then obviously that circle gets bigger and bigger the faster the procession of the matter becomes, that circumference grows proportional to the rate of your velocity. So for each substance there would be an argument about how much how time dilation affects it, and there would be a huge consistency in your understanding that yes, if the object is processing in some consistent mathematical way, that there would be a consistent process of time dilation in the sense that the number of circumferences traveled over a period of distance would be changing at the same rate. But there's no evidence that it affects our perception that way at all, that our perception would be at all on that same scale. As I just pointed out, all I have to do is is expose you to a few G's of acceleration, and I've already broken your fucking clock catastrophically.
Whereas space and time are both personal or relative. I like personal too.
I like personal too. Isn't it? It's just so cute.
But together, space-time is absolute?
So that means space-time, after unification, is absolute. There's nothing personal.
So it doesn't. So it makes no sense, right? They talk about how it's all personal, and then he says, "No, it's absolute, and it's nothing personal about it." It just doesn't make any sense at all. Just none whatsoever. Yeah, there's one universe, and it functions in a very specific way, and you don't change how it functions by changing your viewpoint. Okay, the play that takes place in the theater. Okay, it's the same play, whether I'm in the front row or I'm in the balcony or I decide to go backstage and I can't even see it. It's still the same play on the fucking goddamn stage. It's just such a stupid conversation.
About it, nothing relative about it. We make it personal by the manner in which we observe, the manner in which we move.
So again, no, that didn't make it personal. It was made personal by the fact that we are a thing and we're interacting with a field of photons being ejected by things. I would argue that we're interacting with a lot more than just photons. But anyway, gravitons, magnetons, blah, 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 blah. Yeah, and that's it. That's all there is. And all those little things influence us. Just as all the little events in our life create the reflection that we produce in terms of our emergent properties are all made out of those impacts. Those little days of our lives produce the life we live.
Now, on the other hand, it is so difficult to think about this unified space-time that even I, as a physicist, a large fraction of my work, I make a choice. I will take my personal point of view, and I'll talk about space, and I will talk about time. I'll talk about the warping of space around a black hole, the warping of time, but I will rarely talk about the warping of space-time.
Right. Well, again, let's just understand. So this is before the movie Interstellar was finished. A complete pile of crap in terms of the physics was horrible. The whole idea, he didn't get the whole idea that this is about velocities. It's essentially a thermal question, and you have to have differences in time, okay, to be experiencing a change in your clock that's dramatic, that you'd have to travel, you have to change your velocity. And so the only way to get from a place here where time is moving this fast to a place here that's moving twice as, 10 a million times faster, so you could have a 20-year difference in how 1 minute is experienced, is you'd have to change your velocity dramatically. That is, you'd have to go through a process of acceleration. So there was no 10 G's or 100 G's or 1,000 G's of there was no experiencing of the obligation to change your velocity. That's the key word, okay? No obligation to change your velocity. He made a movie where you didn't have to change your velocity to change the frame you were in, the frame of time dilation. And the only thing that makes the frames different is the fact that they're moving a different speed. So, he violated every one of his own principles. That's how badly he understands his own principles.
Because it's hard for a human to visualize. Our whole senses are attuned to space and time as separate entities, and
so again, this just really has to do with the fact, the thing he doesn't understand is that when I'm standing here on Earth and I'm not moving, I'm still accelerating. It's just a fact. I'm accelerating. I'm moving. I don't see it, but it's happening. That's why the chair gets dented. That's why the floor gets heated. It's because I am in fact moving. The stuff inside of me is moving. So that's the part he doesn't understand. So he thinks you can just, you can stand somewhere and have tremendous velocity, and you don't somehow have to change that velocity. You don't have to acquire that velocity. It just happens to you by some magical thing. I just jump from the planet X to planet Y, and I don't have to experience any change in velocity. When, of course, you do, if you're going to go to some place that has different acceleration.
particularly when I communicate with non-physicists, but also when I do my own research. I slip back into the personal point of view because I have deeper intuitions, or, well, it's easier to think about space and time from the personal viewpoint.
And it's the worst way to do it, right? That's the whole point, is the universe is mechanical, and you have to think of yourself as one gear in a big pile of gears. And as soon as you stop doing that, as soon as you start saying, well, what's it look like from my gear's perspective, then you're failing as a physicist.
Minkowski's block universe has been used by philosophers, even some theologians, in coming up with all sorts of interesting and wildly speculative schema.
So big piles of bullshit have been piled on the bullshit. Yes. So once you make a nice frame, a nice foundation of bullshit, you can make giant bullshit towers.
From a physicist's point of view, how do you see space-time?
So a physicist, stepping back from our universe and thinking about it geometrically and mathematically, thinks of the entire universe as being an entity that we study from outside. And we have the entire future history, the entire past history, all of space going out through the universe.
Right, so they've just invented this silly idea that, we have 3 dimensions that we'll think of in terms of 2 dimensions, a plane, and then we'll just make this 3rd dimension, or the 4th dimension of time, and make it layers on the flat plane of bent space. So they just break the whole idea of dimensions, and to make room for the time dimension. So they essentially get rid of one of the dimensions, up and down, and they just make our reality left and right and forward and back, so they can make time the 3rd dimension, going up and down. They just 3-card Monty cheat.
All of space and time, or unified space-time, as Minkowski would call it. And each point in this 4 dimensions, 1 time dimension and 3 space dimensions, each point is an event. The birth of Abraham Lincoln occurred here. If I think of time as going upward, the birth of...
Yeah, right. So he just did it, right? So yes, if I think of time as one of the 3 dimensions, and so I just throw out one of the 3 dimensions for now, and I just pretend that Abraham Lincoln couldn't jump up and down very well, and so we don't need the 3rd dimension. We can understand his linear, we can understand his life as being something he walked around on a planet. And then we'll make this time thing happening above every one of these events. There's a time dimension that's somehow accessible. I mean, this is just This is worse than nursery rhymes. It's so far from the truth. I mean, Hansel and Gretel has more connection to reality than this nonsense.
Abraham Lincoln occurred here. His death occurred there. His assassination occurred there. During his life, he went through space-time, through this block universe where each point represents an event. He went through space-time, through the beginning of the Civil War, on up to his ultimate death, moving through space-time. And
yeah, that's right. So there's no such place. There's no whatever. So again, this is just, again, do you really believe that? You really believe the past is already some layer somewhere, some place, some dimensional place. It's still there, sitting there in some dimensional place. I mean, you really believe that shit? Oh, just so bad.
he described that his life by a curve in this four-dimensional space-time in this block universe, with space and time unified then in this geometric four-dimensional way.
No, in a three-dimensional way. But you can't do it in a four-dimensional way because you can't draw it, you can't imagine it, you can't figure it out. It doesn't make any fucking sense. There's only room for the three dimensions. There's no room for a fourth dimension. It's just a fact. You're fucked.
But there really is a difference between space directions and time directions. Space directions and time directions are distinguished in that you can always go out in space and come back. You can always go forward in time, but you can't come back. The time has this inexorable flow in the forward direction. So
Yeah. So that doesn't make any sense. A dimension that has a flow in a direction, and again, it doesn't flow in any direction. The only way you get to the future is to go to sleep and wait for it. That's it. That's the only way you time travel, is to close your eyes, go to sleep, and wait for it to get here. You can't make it come to the present. Get to the present, future, jump over here. No, I have to wait for it. So you have to be cryogenically, in some form or other, put to sleep. That's it. That's the only way. And you have to wait for the future to arrive. And that's why you can't go back. It's because you went to sleep to get there. That's the only way to get there, is to become unaware of time.
So it's a very rich block universe with these different kinds of behaviors.
What do you do with the future?
What do I do with the future? I enjoy it as it comes.
But in the block universe, it's already there?
In the block,
You're stealing a ton of money from a doopy public that ended up financing a silly idea. It's disgusting. I mean, it's disgusting that this crap gets unchallenged. He's created a whole bunch of bullshit, put Einstein's label on it, and said Einstein says so. Einstein didn't say any of this shit.
universe, as I step back and think about it mathematically, geometrically, it's already there. The entire universe is there, the beginning, the end, if there is an end. It's a little fuzzy in my mind because I don't know what's up there.
Right, so he has infinity in his little globe already, right? I mean, time, we'd have to argue, is sort of an infinite thing. You're just not going to be able to make it infinite, right? I mean, whatever it was, whether it was nothing or something, the idea of a photon traveling the distance could be imagined, and you can imagine there's still time ticking, so to speak. So how do you do that? How do you imagine your universe with all of its beginning, its origin, and its ending somehow in your little bubble? And what piece do you have? A shred of evidence to indicate that you can do that? No, there's no evidence. And so what would you be arguing? If you're stuck in my position, you're arguing that, well, then your dimension has to keep laying a new floor all the time. Well, why wasn't the floor already there? So you're still stuck with a present where the floors are still being built. It just doesn't. There's just no point in human beings warping concepts that they have no capacity to even understand. You just really can't do anything with beginning, origin, first cause. First cause is a dead question.
I know what's at the beginning. But you describe look, we do it all the time. You have a novel, you read it, the whole story is there. It's in the book, from beginning to end.
Right, and that's what the universe is a book written by a person. No, it's not.
It's all there, but as you read it through, you feel the flow. But it's all there in front of you.
So how then does the future exist in the block universe? Is there some deep philosophical?
The future is here, and the past is there. I don't think that there's.
So, and all of this is, again, this is in the context of physicists with equal credibility arguing for multiverses, which means that this fourth dimension has an infinite number of parallel dimensions. Or 10 to the 127 extra different dimensions that are going off in some other, that obviously go sideways. So it goes up and then it goes sideways. And so they get rid of left and right to fill it full of a bunch of extra planes of reality. All made up.
Any deep philosophy, there's mathematics. Physicists, to some degree, are philosophers of science because we interpret our mathematics. And
again, it's not supposed to be subject to interpretation. I think that's the whole point of formalization. The whole idea is to make it so specific and so rudimentary and so elemental that it's not subject to interpretation. That's the whole point of mathematics. 2 + 2 = 4. It's not subject to interpretation.
we interpret certain pieces of warping of space and time as being...
No, you create fake variables and fake connections between things, like connecting space to time. There's just no connection. Space doesn't equal time. Space isn't proportional to time. Distance is proportional to perception, yes.
The thing that holds us to the surface of the Earth, gravity. We interpret the mathematics, the description of horizons of black holes. You can go in, you can't come out. That interpretation of the mathematics has a certain philosophical...
Yeah, it doesn't have any... the interpretation isn't what has philosophical. No, the bent that created this bullshit in the first place is the philosophical. Why are you forcing reality to be wooey for no reason when you can understand it mechanically? You don't need to create these fake things, these fake ideas. The idea that, light can be bent by gravity, but it can't be retarded by gravity. So yet we're supposed to believe that photons can't escape a black hole because somehow they curve in the black hole and start orbiting the black hole. It's not that they can't take a straight line. So now all of a sudden there's no straight lines again. You can't have a photon leave in a straight vector under equal a force of gravity. Somehow it's going to be forced to bend and be consumed by that change in direction. No, there's no theoretical reason that has to be true.
Content. But philosophers often take this far beyond where we want to go. We want to go only far enough that it is useful to us, that it helps us get predictions out. And at least most of us prefer not to carry the philosophizing farther.
Yeah, predictions that we validate by just saying we did it, and that's it. The predictions aren't proven by some sort of preponderance of evidence, some sort of volume of evidence. The predictions are validated because of a tiny, it seems like, it kind of looks like.
So simply, the block universe has future up here, past down there. That's it. But anyone who lives in the block universe feels the flow of time from past toward future. But I, as a physicist looking in from the outside, just see it as a unified entity.
Yeah, so there's just some trick that we can't hop dimensions without any effort. There's just some trick that prevents that from happening. It just happens to be in there. There's a little catch-22. You can't hop dimensions. I can hop left and right. I can hop up and down. I can hop forward and back, but I can't hop to my, my alternate time dimensions. Oh, it's just a rule. Well, why? Why does that rule exist? Oh, well, it's because the whole thing doesn't make any sense, and if you could do it, then that would prove the whole thing was... If it was possible, you'd find out there is no dimension. You'd jump to nowhere. Again, it's just a God theory. Alright, so... I'll probably do it. There's another one of these, and I'll probably play that in future, next time or something. Because again, this guy is just so full of shit. Just terrible. Horrible. This fraud that's been perpetrated on reason and logic. And Einstein's poor little name. What Einstein has been slandered with is just amazingly evil and such. So, till the next time.